Hello students, today's agenda is to check homework. We'll be learning about vector basics and you will be able to do 6.7. Today students will be able to prove the trigonometric identity cosine square of theta plus sine square of theta equals 1 and find the coordinate of vectors. Okay, so we're going to begin by proving that cosine square of theta plus sine square of theta equals 1. Throughout this unit, we've been learning how to find the sine, how to find the cosine, and even tangent, but we're not going to look at tangent right now. And so to prove this, we're going to be using the unit circle. The unit circle is just aligned so that this point right here is a positive 1 on x. This is negative 1 on y, positive 1 on y, and negative 1 on x. That's why it's called a unit circle, because it's unit. It comes from uno, which is 1, or uno in español. So unit circle, it's 1. And what that means is that from the center to here is 1, but I can draw from that center, I can draw any radius and it will always be the measurement of 1. Okay, so this r is going to be 1, and that's something important that we need to know. So we're going to be using, for the proof, the unit circle together with the Pythagorean theorem, and also the knowledge that we've been seeing through this unit about sine and cosine. Okay, and the circle is a little big, but I'll move this paper up and down so that you can see the work, but also I want you to see clearly what we're doing here. Okay, so in these last lessons, we've been learning that sine of theta is equals to opposite over hypotenuse. Okay, and so in here, if we think about this being y and this being x, so after the proof, we are going to be finding coordinates. And remember that for any coordinate, you always go first on x and then on y. So that's what these values represent. And so when you're talking about the opposite over hypotenuse, opposite is straight across from your angle, right? So it will be this value, which will be y. And the hypotenuse is the longest side in that triangle, so that will be the r, which stands for radius. Okay, so it's going to be sine of theta is equals to the opposite is y over the hypotenuse, which is r. And then we're going to cancel. If we're dividing by r, we're going to multiply by r. These cancel, and you're left with y is equals to r times sine of theta. Okay, that's the value of y. And just to keep it with the same color, I'm going to encircle that. That's something that we are going to be using later. Okay, so that's part of our first, that's the value for y. That's what we're going to be putting in here. For the other one, it's going to be, well, to find x, adjacent over hypotenuse. So it's going to be, for adjacent is cosine. If you remember, cosine of theta is adjacent over hypotenuse. So cosine of theta is adjacent is x over the hypotenuse is r, and we do the same thing. If we're dividing by r, we are going to multiply by r. And again, we find that x is equals to the radius multiplied times cosine of theta. So that's how we find x, the values of x and y, right? Leaving x and y by itself using what we learned for sine and cosine in this unit. Now let's apply the Pythagorean theorem, which we also learned in the previous lesson. And so the Pythagorean theorem which is a squared plus b squared equals c squared. Okay, which means that the addition of the long leg and and short leg, but each one of them squared, is equals to the square of the hypotenuse. Okay, this is A, this is B, and this is C. And with the Pythagorean theorem, we can substitute that with the information that we have here in our triangle. So A and B will always be the two legs. So we can substitute, and it doesn't matter for the legs. What matters is that the hypotenuse will always be C. Okay, so A squared can be X squared, B can be Y squared, equals C squared will be the radius square. Okay, and then we already found in here that X is equals to radius times cosine of theta, so we can substitute that. The only thing is that X is by itself in here, but it's squared in here, so we're going to write it the way it is, but squaring it. Okay, and so we're going to write R times cosine of theta, and all of that to the second power, plus now y is R times sine of theta, all of that squared, because that's what y stands for, and squared again comes from here. Okay, equals the radius square. Now this square belongs to each one of this one. It just means that the R is squared and that the cosine of theta is squared. Okay, so we're going to rewrite that as R squared, then cosine square of theta, plus the same here, R squared and sine square of theta equals to R squared. Finally, we're going to divide by R squared on both sides. We do that in here too. So R squared divided by R squared will be equals to 1. On this side, what we have to do is, I've shared with you the pretzel before. Okay, it just means that when we have addition or subtraction and we're going to divide by a denominator, divide each term. Okay, and so in here, the R squared with the R squared cancel, so you are left with cosine square of theta, plus this also cancels in here, right? First this one and then this one. So now you're left with sine square of theta. And so that's how we prove that cosine square of theta plus sine square of theta equals 1, which is what they were asking us to do here. Okay, if you need to, pause the video so you can copy this demonstration. But before we move on to finding the coordinates, I just want you to notice that to find x is related to the cosine. Okay, so x will be the cosine. Why? Because it's talking about the adjacent side compared to that angle. And for y is related to the sine. Okay, so cosine, sine, and that's because, again, the y is the opposite over hypotenuse. Number 1 says, find the coordinate for the following description. And so before we were doing the unit circle, but in here, the radius will be 5 units. And it's going to be at 45 degrees. Now what we're trying to find is x and y. And for x, as we mentioned, it's related to cosine because it's going to be, this is the value of x, right? And so that's the adjacent to that angle, adjacent and hypotenuse. Again, how do you find the adjacent and the hypotenuse? Remember that the opposite is straight across, so that will be y. Hypotenuse will be the longest side, and adjacent means that it's just the one that is left. Okay, I just do opposite, adjacent, and hypotenuse is the longest. Okay, that's maybe that's gonna help you remember. So for x, you will always use cosine of theta equals, again, adjacent over hypotenuse. Okay, so cosine of theta is going to be the angle measurement, which is 45 degrees. Adjacent is x divided by the hypotenuse, which is 5 units. And in here, now we're going to cancel. If we're dividing by 5, we're going to multiply by 5 on both sides. This cancels, and now we're going to get our value for x. Okay, so there are two important things to know, that you have to check what kind of calculator you have, because sometimes the order is different, and I'm going to write down for both. The other thing is that the calculator needs to say degrees. They have to be in degrees, not radians. So for this calculator, you're going to multiply in this direction. The parenthesis stands for multiplication. Okay, so 45 cosine times 5, and then you press the equal button. Okay, so in that direction, 45 cosine times 5, and then equal. Don't forget equal. So the measurement for here, let's round it to the tenths. So in here it will be 3.5. The 3 doesn't give anything to the 5, so it's just 3.5. And that's the value for x. Again, in the calculator, you're going to write 45 cos times 5, and don't forget the equal. Okay, in the other calculator, you're going to write the way it is: 5 times, and I put times because sometimes we confuse it with x, cosine, and then in here it automatically opens a parenthesis. Okay, so cosine 45, and that's why you have to close the parenthesis, and finally you put equal. Okay, so try which calculator you have. It might be a little bit different. Try which one will give you 3.5, and then that's the path that you have to use, either the pink or the blue one. Okay, so let me show you with this calculator. It's 5 times cosine is right here. See how it opens a parenthesis? 45, you close the parenthesis and press equal. And see, 3.5. Now, if I did it the other way, like I did it in this one, 45 cosine times 5 equals, it's just error. Okay, and the same for the other one. So that's why you have to check which calculator you have to know which path to take, and also that it's in degrees. Okay, very important, because if you're pressing here, it'll change. See, you can have these 3 options: radians or radians, and you want degrees. And same for this one: radians, gradients, and degrees, and we want it in degrees. So we found x. Now let's find y. And so for y, we said that it's going to be sine. So sine of theta equals opposite over hypotenuse. And the opposite in here, and sine of 45 is equals to opposite. Opposite is y over hypotenuse, which is 5. And again, if we're dividing by 5, we're going to multiply by 5 on both sides. And so y is equals to, I will continue to use this calculator. So remember, you just go backwards with that one. 45 sine times 5 equals. And it's also 3.5, but it's because it's a 45, 90 degree angle. Okay, so 3.5. And so that's going to be our unit. That's what we're looking for. Okay, that's the coordinate that we are looking for. Okay, in your homework, this is how it's going to look. And so you have to draw the little diagram. It doesn't have to be to scale. And so 12 degrees it's going to be tinier than this, but that's okay. So 12 degrees will go in here. The 3 units is your radius. Okay, and so we start. Again, we're trying to find the coordinate for that point, and x is going to be your cosine and y will be your sine. Okay, so let's start with cosine of theta is equals to adjacent over hypotenuse. And so cosine of theta, theta is 12 degrees. Adjacent, again, is going to be your x divided by the radius, which is 3, or the hypotenuse. If we're dividing by 3, the opposite is to multiply by 3. This cancels, and x will be equals to 12. Remember that it's in this direction, 12. Cosine times 3 equals 2.9. 2.9 for x. Okay, that's the value for the x coordinate. Okay, now y, which is sine of theta, equals opposite over hypotenuse. The more you write the formula, the better you get to remember. Okay, so sine of 12 equals opposite is going to be y divided by hypotenuse is going to be 3. If we're dividing by 3, the opposite is to multiply by 3. This cancels, and y is equals to, again, in this calculator, we go backwards, which is 12 sine times 3 equal, and it's 0.6. The 2 doesn't give anything to the 6, so it's just 0.6. So that's the value of our y coordinate. Okay, 0.6. And so that's the coordinate that we're looking for. Now let's go to number 3. And so in here it says that we have 11 units at 77 degrees. So somewhere around here, this is 11 units and 77 degrees. So again, for cosine, will give us the x. Cosine of theta equals adjacent over hypotenuse. Cosine of 77 equals adjacent is your x divided by hypotenuse, which is 11 units. If we're dividing by 11, the opposite is to multiply by 11. This cancels, and x is equals to, in this calculator, we go in that direction. On this calculator, basically, is going in this direction, okay? Because you just input it as it is, 11 times cosine 77, close parentheses, equal. Okay, so it's just following exactly the way it is. 11 times cosine 77 equal. And that's going to be 2.47, which gives you 2.5. The 7 is bigger than 5, so you round it up. If it's 5 or more, this goes 1 up. If it's 4 or less, this stays the same. So remember that it's backwards on this one. 77 cosine times 11 equal 2.47. Okay, the same on both calculators. So that's the value for x. X is 2.5. Now let's find y. So for y, it's going to be sine of theta equals opposite over hypotenuse. Sine of theta is 77 equals opposite is your y, and hypotenuse is 11. It's the radius of that circle or the hypotenuse. And if we're dividing by 11, we multiply by 11. This cancels and y is equals to, again, you go backwards on this calculator, so 77 sine times 11 times 11 equal. So the y value is 10.7. 10.7, and we're done with this coordinate. Okay, for number 4, it says 2 units at 120 degrees. There are 2 different ways to do this one. And so the first thing that we need to know is that in the coordinate plane, this is 90 degrees. That means that it's going for the 120 degrees. You go a little over that. So basically, you're going on the second quadrant. Okay, so let's do it with the 120 degrees. For your x value is going to be cosine of 120 is equals to x over 2 units. If we're dividing, the opposite is to multiply. This cancels, and x is equals to, we put 120 cosine times 2 equals, and it gives you -1. Okay. Oop, I put it in blue this time. That's fine. -1 for x, and you notice that it's going on the left. Now for y, it's going to be sine of 120 equals, and I didn't even put the formula, opposite, which is your y divided by the hypotenuse, which is 2. If we're dividing by 2, the opposite is to multiply. This cancels, and so y is equals to 120 sine times 2 equal, which is 1.7. Okay, and so the y value is 1.7. Again, we have our coordinate. The other way that you can do it, I'm going to write it right here, is to actually use, if this is 120, that means that this is 60 degrees, and it helps you also prove that this is correct. Remember, opposite is straight across from that angle, right? And adjacent is always the one that it's to the side, but not the hypotenuse. Okay, so opposite, adjacent, and hypotenuse. Okay, so again, for cosine of theta equal adjacent over hypotenuse, cosine of 60 is equals to, adjacent is going to be x divided by the hypotenuse, which is 2 units. You multiply by 2. This cancels, and x is equals to 60 cosine times 2 equals 1. The only thing that you have to do is that because you're doing it on this side, you know that it's going left, then you add the -1 once you're placing it in your coordinate. Okay, that's the only thing that you would have to do if you decided to use this angle in here. For the y, it would be sine of theta equals opposite over hypotenuse. Sine of 60 equals opposite is y divided by hypotenuse, which is 2. If we're dividing, the opposite is to multiply. This cancels, and y is equals to 60 sine times 2 equals 1.7. And then you check that it's going up, so it's going to stay positive. We don't change the sign to negative once we write it here for the 1.7. So that's the end of our lesson. If you can give us a thumbs up subscribe around here. This is the link to all the videos on this unit, which is sine, cosine, and tangent, Pythagorean theorem, and here will be our next video. Have fun!